The A320 electrical system is quite similar to electrical systems which you are familiar with. It is simply more automatic and easier to use. There are two engine-driven generators. The generators maintain a constant speed by a drive mechanism known as an integrated drive generator, IDG. Each generator supplies alternating current, AC, to its own bus. Generator 1 to AC bus 1, Generator 2 to AC bus 2. Each AC bus supplies its own transformer rectifier, TR. AC bus 1 to TR1, AC bus 2 to TR2. The TRs convert alternating current into direct current, DC, to supply their associated DC buses, DC1 and DC2. DC bus 1 then feeds the DC BAT bus, DC BAT. The DC battery bus can charge the batteries or receive power from the batteries as required. This will be further explained in normal operation. The electrical system also includes two essential buses. The AC essential bus, fed by AC bus 1, the DC essential bus, fed by DC bus 1 via DC BAT bus. This is the basic electrical system. We will now introduce some other components which supply the basic system. The electrical network can also be supplied by the APU generator. These three generators are all identical, and any one of them can supply the entire aircraft electrical needs. On the ground, the aircraft can be supplied by an external power source. As a backup, there is a hydraulically driven emergency electrical generator, Emergen. The hydraulic power to drive the emergency generator is provided by a ram air turbine, RAT, located in the belly fairing, which extends in case of severe electrical or hydraulic failures. The electrical system is also fitted with an essential transformer rectifier, essential TR. The essential TR can power the essential DC bus from the emergency generator in case of severe electrical failure. Note, we will see the emergency generator and the essential TR in detail in the abnormal operation module. Finally, a static inverter allows part of the AC electrical network to be supplied from BAT 1. Now, let's see how this information is presented to the pilots in the cockpit. We will introduce the ECAM electrical page. You can see that most of the components we have talked about are displayed on the ECAM page. Let's briefly review the basic system using the ECAM electrical page. Gen 1 and Gen 2 supplying AC bus 1 and AC bus 2. TR1 and TR2 supplying DC bus 1 and DC bus 2. Two essential buses supplied by the left side. the DC BAT bus, and 2 batteries. Notice that the static inverter is not displayed on the ECAM page. For simplification, the component indications had been removed. Let's now present them. As shown, each component can be monitored via its indications. These indications are voltage, current or load for the generators, frequency, IDG temperature. You can also notice the different connections displayed via green lines. Let's now locate the various controls available to the pilots and associate them with the components displayed on the ECAM. The electrical panel is located on the overhead panel. For emergency cases, there is an emergency electrical power panel on the left side of the overhead panel. Now let's look at the relationship between the electrical panel and the ECAM electrical page. The battery voltage can be monitored either on the overhead panel or on the ECAM page. Each battery is controlled by a push-button switch. Both main generators and the APU generator are controlled by their associated push-button switch. The external power is also controlled by a push-button switch. We will learn how to use it in the normal operation modules. The AC Essential Feed push-button switch enables the pilots to change the feed for the AC Essential bus from AC Bus 1 to AC Bus 2. The Bus Tie push-button switch enables the pilots to isolate one side of the system from the other. You will see and do this in the abnormal operation modules. In case of failure, these push-button switches enable you to disconnect an IDG from its drive shaft. The controls and indications on the emergency electrical power panel will be covered in the abnormal operation modules. There is one exception. The emergency generator test switch is used by maintenance only to test the emergency generator. In this module, you have seen the electrical configuration on ground, with both engines running and with APU generator and external power available. We will introduce the different possible configurations in the next modules.